Hello, this is Mrs. Scarpo, and this video I'm going to cover the retrieval for Lesson 1 of Unit 2. In this particular retrieval, we are starting with a graph of y equals 3 to the x, or f of x equals 3 to the x. That's going to be this black curve that you see on the graph here. The green graph is the graph of g of x. It's a transformation of f of x. So just take a little bit and take a look at what you think is different, and I'll point out a couple of things that are different ways you could be looking at it. But yeah, just take some time, take a look at this graph, compare the points that have been plotted. So if we take a look at the 3 points that are highlighted here on the graph of g of x, we don't have the ordered pairs written next to them, so that's what we're going to do for part A, is write those ordered pairs. So we have one ordered pair down here at -1, +1. And I'm also going to write it on the graph, -1, +1. We have another point at 0, +3. Include that on the graph. And then we have a third point at 1, 9. Now, as I mentioned, there could be a couple of different ways you see this. You might see that each of these points on the green graph is just one unit to the left of a corresponding point on the original graph of f of x. So we might describe it as a shift or translation. That's the academic term for the shift, to the left, one unit. But you might also see that each of these points on g of x is directly above a point on the graph of f of x, the black curve. And if you take a look at the y values, the y values of g of x are 3 times the y values of f of x. So you might also say that it is a vertical stretch, and we're calling it a vertical stretch because the points moved higher, of 3. And the reason it's of 3 is because the y values of f of x are multiplied by 3 to get the y value of g of x. Because we have two different translations or transformations that could be generated or described, I'm going to write two different equations. I'll write one for the translation and one for the vertical stretch. For the translation, that's going to be g of x equals, f of x was the graph of 3 to the power of x, so 3 to the power of, and because it shifted to the left, it becomes a +1 added to our x value. So you might remember when you worked with quadratics in a previous course that when you have a horizontal shift, the direction of the shift is opposite of the sign that you see after the x and then the number of units it shifted. So this is for the translation. For the vertical shift, I mentioned that we're multiplying the y value times 3. So this, or the vertical stretch, excuse me. So that's just a matter of taking 3 times 3 to the power of x. And actually, both equations are equivalent, because our properties of exponents would tell us for this vertical stretch that we could add our exponents together, which would give us that 3 to the power of x plus 1. But either of these equations would be correct. Now, in the assignment, it isn't necessarily going to be that you're given one equation and the other one on the same graph. What's going to happen, and I'll just go through number 1a, or I guess it is just number 1 with you. One thing the book says is for the domain of -4 to +4. So what I would recommend is you create a table, an XY table, and use all of the values from -4 to +4. And to find the value of y, you're going to put -4 in to that equation. So 2 to the -4 is going to be the same as 1 over 2 to the 4th. That's going to be 1 over 16, or 1/16. 2 to the -3 is 1 over 2 cubed, is going to be 1 to the 8th. 2 to the -2, excuse me, let me write this correctly. 2 to the -2 is going to be 1 over 2 squared, which is 1/4. 2 to the -1 is going to be 1 over 2 to the 1st, or 1/2. 2 to the 0 is 1. 2 to the 1 is 2. 2 to the 3 is 8. And 2 to the 4 is 16. So we can plot these points. 1/16 is going to be pretty much right on top of that x-axis. 1/8 isn't going to be much higher. 1/4 a little bit higher than that. 1/2 at -1, 0, 1, 1, 2. Oh, I missed 2 squared here. Excuse me. So 2 squared is 4. 2 cubed is 8. 2 to the 4th is 16. And you'll see that we have this exponential curve that's happening. And then for number 2, it's going to be some variation of this. So what I would recommend is, rather than create another table for number 2, is take these values that we found for y in this table and apply whatever change is happening to these values, and then plot them. It'll have its own grid graph for you to graph that curve. And then you'll be able to see how the curves are different, how the graphs are different based on the change. The other thing that you're going to see in your assignment is rewriting exponential expressions. Remember, we talked about when we have a negative exponent, the part that has the negative exponent moves to the other side of the fraction. So in this case, 24 moves to the denominator. 16 actually moves to the numerator. And the reason they both moved is because they both have a negative exponent. So this is 16 over 24, but it says in lowest terms. 8 goes into both of these numbers. So I'm going to basically divide both of these numbers by 8. and we're going to have 2/3 is the equivalent. Now in the assignment, we're applying all of the properties of exponents, or especially, well, yeah, we're going to use some division exponents. We're going to use that anything to the 0 power is 1. So you're going to be given a sheet with all of the properties of exponents. Use that and look back, if you still have your Unit 1 workbook, look back at some of our other assignments where we did things with exponents to see how they simplify. Keep in mind you can also check answers on Schoology, as I have posted the answers there.